Today we are on our last lesson of Unit 12, Lesson 7, More Probabilities. It starts on page 435, and we'll be covering page 435 and 436. We will not be doing page 437. The only thing you need is a calculator for our simple operations or adding, subtracting, multiplying, or dividing. And the homework pages are 438 to 439. You are to omit number 3 on page 438. So we start with a summary, our formula summaries. For any event A, the probability of not A, which in symbols I use the tilde symbol, which would be the probability of not A, is equal to 1 minus the probability of A. For any two events A and B, the probability of A given B, remember our symbol for given, I'll just put it below here. It's that vertical segment. So the probability of A given B is equal to the probability of A and B divided by the probability of B. The addition rule states for any two events A and B, the probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. Remember our symbol for and. The multiplication rule for independent events. So if events A and B are independent, then the probability of A and B would equal the probability of A times the probability of B. And events A and B are independent if and only if. So independent if the probability of A and B equals the probability of A times the probability of B, or they're independent if the probability of A given B equals the probability of A. Example 1, when a car is brought to a repair shop for service, the probability that it will need the transmission fluid replaced is 0.38. So transmission fluid replaced, 0.38. The probability that it will need the brake pads replaced is 0.28. And the probability that it will need both the transmission and the brake pads replaced is 0.16. Let the event that a car needs the transmission fluid replaced be capital T, and the event that a car needs the brake pads replaced be capital B. What are the values of the probability of T? So the probability of T, transmission, is 0.38. The probability of B, brake pads replaced, is 0.28. And the probability of T and B is 0.16. Use the addition rule to find the probability that a randomly selected car needs the transmission fluid or the brake pads replaced. So transmission or brake pads. The probability of transmission or brake pads, using our formula for or, is equal to the probability of transmission plus the probability of brake pads minus the probability of T and B. Replacing probability of T with its value, 0.38, 0.28 minus 0.16. Go to the calculator. .5. Example 2, Josie will soon be taking exams in math and Spanish. She estimates that the probability she passes the math exam is 0.9, and the probability that she passes the Spanish exam is 0.8. She is also willing to assume that the results of the two exams are independent of each other. So if these two exams are independent of each other, then we want to use the multiplication rule for independence above, which is the probability of A and B would equal the probability of A times the probability of B. Using Josie's assumption of independence, calculate the probability that she passes both exams. So I'll use M for math, S for Spanish. The probability of M and S, again, assuming that they are independent of each other, would equal the probability of math times the probability of Spanish. Math is 0.9 times probability of passing Spanish is 0.8. So if we multiply these two, 0.9 times 0.8, 0.72. Find the probability that Josie passes at least one of the exams. Well, passing at least one means she passes either math or Spanish. So we'll use our probability of math or Spanish. And the formula for OR is, and at this point you shouldn't have to look back at the top of the page where you should know the probability of M or S is going to equal the probability of M plus the probability of S minus the probability of M and S. .9 plus 0.8 minus what we just found in A, 0.72. Well, 0.9 plus 0.8 is 0.17 minus 0.72 I think I said 0.17. I was supposed to say 1.7. 1.7 minus 0.72 is 0.98. Top of page 36. Oh, a new term here. Disjoint and mutually exclusive. Two events that have no outcomes in common. No outcomes in common are called disjoint or mutually exclusive. They mean the same thing, referring to two events that have no outcomes in common. If A and B are disjoint events, then the probability of A or B is equal to the probability of A plus the probability of B. Because minus the probability of A and B, well, they have nothing in common. So the probability of A and B would be 0. So if the events A and B are disjoint, the Venn diagram looks like this. Right? There's no overlapping region. They have nothing in common. Another way of describing disjoint events is by saying that they cannot both happen at the same time. Thus, when two events A and B are mutually exclusive, then the probability of A and B equals 0. And in symbols, and looks like this rounded capital A without the horizontal bar. So the probability of A and B equals 0. For example, if a die is rolled once, then the events the result is even and the result is a 5 are disjoint, since even and 5 cannot both happen on a single roll. But the events the result is even and the result is greater than 4 are not mutually exclusive, since getting a 6 results in both events occurring. Example 3. A pair of dice is rolled. Two possible events are rolling a number greater than 8 and rolling an even number. Are these two events mutually exclusive? Okay, so we're looking at rolling a number greater than 8 and rolling an even number. Now this is a pair of dice, all right, which is kind of, we have the outcomes here. If we were to roll a 1 on the first die and the 1 on the second die, then we're looking at the sum. So the sum would be 2. We could roll a 1 and a 2, and then the sum would be 3. So our evens, we would have 2, 4, 6, 8, and then 10 and 12 would go in here in the overlap region because they're also greater than 8. And greater than 8, we would have 9, 10, 10 is in the overlap, and 11. Are these two events mutually exclusive? Well, they are not. They are not mutually exclusive, since a 10 and also a 12 are results in both. Example 4, a pair of dice is rolled. The possible events are rolling a number less than 5. That would be a 2, 3, or 4. And rolling a number which is a multiple of 5. Multiple of 5 would be 5 or 10. Are these two events mutually exclusive? Yes, they are. They have nothing in common. Example 5. The addition rule for disjoint events. A set of 40 cards consists of 10 black cards showing squares, 10 black cards showing circles, 10 red cards showing X's, and 10 red cards showing diamonds. A card will be selected at random from the set. Find the probability the card is black or shows diamonds. So use B for black and D for diamonds. All right, so the probability of the black or diamonds is going to equal the probability of black plus the probability of diamonds minus the probability of black and diamond. Well, how many black cards are there? there's 10 black squares and 10 black circles. So that would be a total of 20. So that's 20 out of 40 of the cards are black cards. Probability of diamonds, there's 10 diamonds. Probability of diamonds, 10 out of 40. Minus the probability of black and diamonds. Well, there are no black diamonds, so that probability is 0. So 20 over 40 plus 10 over 40 is 30 over 40. Or the decimal equivalent, or the reduced fraction, or a percentage. Okay, so we are not doing page 347. And your homework, which is pages 438 and 439. You are omitting number 3. Okay, so just omit number 3 on page 438. And I just want to point out that on page 438 as well, number 2, it says to draw a Venn diagram to represent the information. Let's just add to that. You can draw a Venn diagram or a two-way table. And I thank you once again for your attention.